and welcome to ROHM Semiconductor. My name is Maurer and I'm acting as Product and Application Marketing Manager, responsible for ADAS applications as well as PMICs and DC-DC regulators for the automotive industry. Today, I want to present the Nano Pulse Control technology invented by our engineers. Nano Pulse Control, what's that? It's a new invention for fast switching buck regulators with very short on times for the high side FET. Such short times enable a direct voltage conversion from high input to low output voltages with small externals such as inductors and capacitors. What challenges do we have for such kind of switching regulators? First of all, today's sweet spot for high-frequency switching buck regulators is in the range of 2 to 2.5 MHz. This ensures no disturbances with the AM band and reduces the inductor value as it is in inverse proportion to the buck switching frequency. The faster the switching frequency, the more difficult designing stable feedback loops. A major impact comes from the chip parasitics, which will cause effects like ringing. Another challenge is the ratio between the input and output voltage. The higher the ratio between input and output voltage, the shorter the on time of the high side switch. Here an example. Let's assume a buck regulator switching at 2 MHz and an input voltage of 48 volt. The buck output voltage shall be 2 volt. Now we can calculate the T on time of the high side switch while dividing V out by V in and the switching frequency. As you can see, the on time of the high side switch is already down to roughly 20 nanoseconds, which is not achievable by traditional regulators. How do application designers solve these challenges? One possibility is to reduce the buck switching frequency at the cost of higher inductor values, increased form factors of the external components, and often worse efficiency values due to higher inductor DCR. A second approach is to cascade two buck regulators, but this would increase the cost due to the additional silicon and corresponding external components. Furthermore, the PCB area would be increased, roughly doubled, and the overall conversion efficiency is the product of both efficiencies. The third and most attractive solution is ROHM's Nano Pulse Control DC-DC switching regulators, a single chip conversion solution eliminating the disadvantages of the former mentioned approaches. ROHM's Nano Pulse Control technology solves this situation as the new innovative technology allows going down to 9 nanosecond high side FET on times for our new generation of products. This innovation reduces the minimum on time of the high side FET by a factor of more than 13 compared to former ROHM products. Our engineers solved the problem that the switching pulses are overlaid by ringing caused by parasitics, as well as the fact that smaller high energetic pulses will generate significant higher ringing. The resulting waveform on the high side will make it nearly impossible to measure the inductor current, which is essential to design stable buck feedback loops. ROHM engineers invented a method measuring the inductor current not affected by the ringing. A key feature of this invention is the variable sampling, which avoids error measurements. Nano Pulse Control technology solves all technical issues and offers now buck regulators with high side FET on times down to 9 nanoseconds. Here you can see an overview of the automotive primary buck portfolio, including Nano Pulse Control technology. Products are split into classes of output current capabilities from 1 amp up to 5 amp, as well as groups with variable and fixed output voltages. As an example, BD9P105 requests an external resistor divider to define the output voltage, whereas BD9P135 generates 3.3 volt fixed. Most of the regulators are offered in HT SSOP and QFN package and include multiple safety features like overcurrent protection, short circuit protection, thermal shutdowns, and furthermore. The regulators are designed using N-channel FETs only and offer high voltage conversion efficiency even at high switching frequencies up to 2.3 MHz. Please have a look onto the efficiency curves for 2M buck regulators converting a 12-volt input voltage to 5 volt and 3.3 volt. Both graphs show the conversion efficiency in PWM synchronous mode in red and the auto mode in blue. You can see the outstanding overall and almost flat light load efficiency for output currents down to 1 milliamp, even for output current of only 100 microamp. The conversion efficiency is in the ballpark of 70%. Another quality attribute is the transient load response. Especially for buck regulators operating in auto mode, significant load changes can be a challenge. The graphs below show the output droops and overshoots for the load transition from 0 to 2 amps and back to 0 amp again for the BD9P255. As you can see, the overshoots and droops are in the same range of the buck operating in forced PWM and in auto mode. ISO 16750-2 describes tests for electronic equipment in the automotive industry. One key test is checking the reaction to input voltage fluctuations. The slide compares the output voltage reaction to an input voltage droop from 16 volt down to 8 volt and back. While comparing BD9P255 with a competitor device, you can see that the ROHM regulator has a significant better output stability at the same switching frequency and output capacitance. This will become even more significant if the fluctuation will go down to 4 volt. The right graph on this slide shows the overshoot of around 700 mV for a competitor buck regulator, whereas the overshoot of ROHM's BD9P255 is around 14 times smaller with its 50 mV. Nano pulse control technology is not limited to primary bucks only. ROHM engineers have also integrated this innovation into secondary buck regulators. This line-up is set in a similar way than for the primary bucks. You can see the output current capabilities. ROHM also offers variable and fixed output voltages for the secondary buck regulators. Another point to be mentioned is the small package of 2 by 2 mm, whereas the compensation network is included in the chip to ensure the small form factor solution. As a summary, ROHM's nanopulse control is an innovative new technology for switching DC-DC regulators that operate at high switching frequencies, offer high input to output voltage ratio, with very outstanding electrical performance, while using small electrical passive components at low cost and small package and solution form factors. For further information, please visit our webpage under rohm.com/products/power-management/switching regulators or contact us via rohm/contact us or register to my ROHM.